Okay, so in the last video we talked about acceleration, right? And so the acceleration allows us now to create different types of graphs that we know as velocity time graphs. So velocity will be on the y-axis, and time, again, will be on the x-axis. Okay? So when talking about acceleration, we begin our second visualization or graph of motion. We know this graph is a velocity versus time graph, or a VT graph. Now, again, I mentioned in the beginning of the video, it says time again will be on the x-axis, while velocity will now be plotted on the y-axis. Two pieces of information that you can get from this graph. Okay, again, if you think about the acceleration equation, delta v over delta t, well, that looks like a slope. Well, guess what? Acceleration, or average acceleration, is the slope of a VT graph. Okay, now the displacement is where we're going to do calculus, but not calculus. This is what I like to tell students. Okay, so we're actually going to use a calculus principle here, but we're not going to use the actual calculus function. And that's what we're going to do is we can find the displacement of an object by finding the area under the curve. Okay, so simple enough. In AP Physics 1, all of our areas are going to be squares, rectangles, or triangles. Okay, and so we just, like, if I want to find the displacement of this piece, I'm just going to do 1/2 base times height. If I want to find the displacement of this piece, I'm just going to do base times height. And you just piece it together, okay? And then when you piece it all together, that would give you this displacement of the object for the entire time, okay? Some things about this: the axis is when the object is at rest. So notice that this object starts from rest and about 30 seconds goes back to rest, which means it turns at this point, okay? And that's what that means on the graph, and then it'll come to rest, okay? Now, here's a good, this is from an old AP exam, okay? So this says the accompanying graph describes the motion of a toy car across the floor for 10 seconds. Or 59 says, what is the acceleration of the toy car at 4 seconds? So we're trying to find the acceleration at this point. What they're going to try to do here is try to trap you into, oh, it's on the axis, so that means that the velocity, the acceleration has to be 0. Okay, it is not going to be 0, because what we need to do is we need to find the slope at that point. Because remember, acceleration is the slope of a graph, okay, of a VT graph. And so what we do is we say acceleration is delta v over delta t, or rise over run. And so I'm going to go to this point as I'm going to look at it this way, okay? And so it tells me my displacement is, my final velocity is 2 meters per second. My initial velocity is -1 meter per second, okay? And then I'm doing this all in, 1, 2, 3, so it's at 3 seconds, so 1, 2, 3 seconds, okay? And so 2 minus -1 is 3, so it's 3 over 3. So it's going to tell me that my velocity is a positive, or excuse me, my acceleration is a positive 1 meter per second squared. We know this is a positive acceleration because my slope is positive, right? So I have a positive slope. So anything with a negative, I can cancel out, okay? You can just, so test taking strategy, look at the picture. You know what slopes look like. You know what a positive slope is. You know what a negative slope is. If it's looking for acceleration and you have a positively sloped line, guess what? You can cancel out negatives. And if you have a slope line, right, like how this is a slope line, your acceleration is definitely not 0. Now, this is where your acceleration would be 0, okay? That's a constant velocity piece, right? Down here, your acceleration would be 0. But anytime you have a slope line, your acceleration is not 0. So through our math, we found that our answer would be C, 1 meter per second squared. Okay, now this is asking us, what is the total displacement of the car for the entire 10-second interval shown? So I'm going to break this up into pieces. And I'm going to find the areas for all those pieces. And I'm going to do it kind of quick. So this is going to be 1/2 base times height. So you do have to take into account the negative sign, okay, because we're looking at displacement. So I have 1/2 times 2, which is 1, times -1. So that area is going to be -1. Okay, now I have 1 times -1. That's going to be -1. Okay, and then I have 1, because again, we're looking at the base, not the numbers, right? This is like 3 seconds. This is 3 seconds. This is 4 seconds. So 4 minus 3 is 1. So I have 1/2 times 1, which is 1/2 times -1, which is -0.5. Okay, now when you see the graph go under the axis and above the axis is the base of the triangle. So there are 2 separate triangles at this point in time. Okay, it's not one giant triangle. So for that area that's underneath, and we'll call that like area 1, that's going to be -1 plus -1 plus -1/2, so -1.5 meters. Okay, now for the second part, I have 1/2 times 2 is 1, times 2 is going to be 1, right? Positive 1. Oh, I apologize, it's going to be 2, because 1/2 times 2 times 2. And I have 2 times 1, 2, 3. So 2 times 3 is positive 6. Okay, so what you can see here is we're already bigger than 0 meters, right? So we're not going to, because if we add all this up, it's definitely not going to be 0 meters. And over here, even though this is a negatively sloped line, it's still on the positive side. So it's going to be 1/2 times 1, so it's 0.5, times 2, so this is going to be plus 1. So this area, so what I'm going to call area 2, is going to be 9 meters. Okay, and I don't see, let me make sure I did this right, because I don't see, if I do 9 plus 1.5, or -1.5, it should be 7.5. So let me just double check. So 1, 2, 3 times 2 is 6. 1/2 times 1 times 2. This is 2 times 2, right? So 2 times 1, right? And this is 1 times -1, and this is 1/2. So if I add all those up, I'm going to do -1 plus -1. Okay, so -1 plus -1 plus -0.5 plus 2 plus 6 plus 1. Okay, and lo and behold, I thought it equals 6.5, but it actually does, or 7.5. It does actually equal 6.5. Okay, so there must be -2, it's -1.5, 8, 9. It's -2. Oh, silly Mr. Londa. That should be -2.5, not 1.5. Okay, so that is how we interpret velocity versus time graph, which is our